Okay, this is a video about arc length and sector. And I know it's not ideal to learn from a video, but it's better than nothing, and we will practice it more when I get back. Okay, there's two different things, and even though they're different, they both are found the same way, so we put them together. So the first is arc length, and arc length is a piece of the circumference. And if we were to look at a picture of a circle, here's my circle, and if I put 2 points on it, what we have talked about is arc AB. And arc AB is the shortest distance between those 2 points. And what we have been finding is there's 360 degrees in a circle. How many of those degrees are used in that arc? But now we're going to say, well, if this circle is made out of string and I cut it at A and cut it at B and stretched it out, how long would that little piece be? And the formula is found by taking the degree over 360 times the circumference. Okay. The next one is a sector, and we're going to be finding the area of a sector. And a sector is a piece of the area of a circle. And if you remember, if we look at a sector is going to look like a slice of pizza. And the formula for a sector is degree over 360 times the area. All right, now that we've got those, let's go ahead and practice using them in our formula. So on the first one, if the radius over here is 9 yards, that means the circumference is 18 pi yards, and the area is going to be 81 pi yards squared. Now this last or third box here says that it wants M arc AB, and that M stands for the measure of arc AB. Okay? And they want the degree. So because this is a central angle, we know that this is 80. Well, now that we've got that, now we can find these two things. This first one with no M in front of it, they're asking for the arc length. And so we're going to do the degree, which is 80, over 360 times the circumference, which is 18 pi. So now we are going to, now normally when you multiply straight across the top and straight across the bottom, which is what we are going to do, but we're not going to do that until we reduce first. So I'm going to start with just the 80 over 360. Since they both end in 0, I can divide them by 10, and when I do that, the zeros cancel out. Now I'm left with 8 over 36. 8 over 36, I can divide both of them by 4, so this is going to be 2 over 9. Now that I reduce vertically, now I can reduce at an angle. The only way we can't reduce is left to right, but up and down and at a diagonal works. Okay, so 2 over 9 is reduced, and now I'm going to try 9 over 18. Well, 9 goes into itself once and an 18 twice. So on the top, I have 2 times pi, which gives me 4 pi. And on the bottom, everything canceled out except the 1, so I don't have to write it. So it's just going to be 4 pi yards because it's a length. All right, now we're going to repeat this again, but this time we're going to find the shaded area, and the shaded area is a sector. So we're going to use a sector formula. So it's going to be the degree 80 over 360 times the area. Now, on these, it's important to work smarter, not harder. This is my formula, but just in the green one over here for arc length, we discovered that 80 over 360 reduces to 2 over 9. So you actually don't need to even write this one. I just start with 2/9 times 81 pi. Well, 2 and 9 don't reduce anymore, but 81 and 9 do. 9 divided by 9 is 1. 81 divided by 9 is 9. Now multiply straight across the top. 2 times 9 times pi is 18 pi. And on the bottom, we just have a 1. And then it's going to be yards squared. All right, let's try this again. Number 2. Number 2, the radius is 5, so that makes the circumference 10 pi inches. That makes the area 25 pi inches squared. And then this one right here, because the M is front of it, they want the measure here. So that is the degree. Well, it's a central angle, so the angle meets or matches the arc. So this is going to be 100. Okay, then they want arc AB. This right here is the arc length. And arc length is the degree 100 over 360 times the circumference, which is 10 pi. Well, since they both end in zeros, those will cancel. 10 over 36, I can reduce and divide it by 2. 10 divided by 2 is 5, and 36 divided by 2 is 18. Okay, I cannot reduce any more vertically. Now, before I keep going, I'm going to quickly come over here and write 5 over 18 because I know that's what my fraction is going to reduce to later on. And now I'm ready to go for the next one. Okay, let's keep reducing. I reduced vertically, so now I'm going to go at an angle. 10 and 18, the only thing that goes into both those is 2. 10 divided by 2 is 5. 18 divided by 2 is 9. So I'm multiply straight across the top. 5 times 5 times pi is 25 pi. And on the bottom we have 9, and the label is inches. And then to complete the shaded area, remember this is your sector. And the sector is degree over 360, which we discovered was 5/9 or 5 over 18, okay, times the area, which is 25 pi. Now, 25 or 5 and 18 can't reduce any, but we can check the diagonals, but 18 and 25 can't simplify either. So now we're going to multiply straight across the top. 5 times 25 times pi is 125 pi. And on the bottom, we get 18. And because it's area, it's going to be inches squared. Okay. Here's our next one. Number 3. The radius is 8. So that means the circumference is 16 pi centimeters. Since the radius is 8, the area is 64 pi centimeters squared. And the measure of the arc, well, because this is 145, it's a central angle, so the arc matches. So this is 145. Remember, this one over here is just the degree. For the other one, where we have the bigger box, that's where we're going to find the arc length. So the arc length is the degree over 360. That's the fraction of the circle that we want. And for arc length, we want a fraction of the circumference, so times 16 pi. Now, we need to simplify this fraction. So 145 divided by 5 is 29. 360 divided by 5 is 72. Okay, 29 and 72 isn't going to reduce anymore. So I'm just going to write this fraction over here because I know I'll need that later. And now I can go ahead and finish this. 29 and 72 won't reduce anymore, but 72 and 16 we can reduce because we can divide it by 8. 16 divided by 8 is 2. 72 divided by 8 is 9. So now I'm going to multiply straight across the top, and I'm going to get, 29 times 2, which is 58. So this is going to give me 58 pi over 9. All right, now for the next one, the sector is a fraction of the area. So I've got my fraction, and now I'm going to take it times the area, which is 64 pi. Okay, again, 29 and 72 can't reduce, but now I'm going to look diagonally. I can divide those by 8. 64 divided by 8 is 8. 72 divided by 8 is 9. So now I'm going to multiply straight across the top. 29 times 8 gives me 232 pi. And on the bottom, we get 9. Need to go back and add the labels. So the area of the sector is centimeters squared, and the arc length is just going to be centimeters. Okay, just 2 more. On this one, we want the circumference. Well, the radius is 7. The circumference is 14 pi feet. The area would be 49 pi feet squared. Now, this one wants the measure of arc ACB. So it means it starts at A, goes through C, and ends at B. So it's not 60. It's the other portion of the circle. So that means we're going to have to do 360 minus 60, which would give us 300. And that's what goes there. So for my arc length, I'm going to take the degree, which is 300, over 360 times the circumference. Well, since they both end in zeros, I can divide by 10 and those cancel out. In 30 and 36, I can divide them both by 6. 30 divided by 6 is 5. 36 divided by 6 is 6. So that's going to reduce to 5/6. So I'm going to write this fraction over here so I don't get confused later and remember what my fraction is. So I've reduced up and down. So now I'm going to do a diagonal. I can divide both of those by 2. 6 divided by 2 is 3. 14 divided by 2 is 7. So multiply straight across the top and get 35 pi. And on the bottom, all I have left is 3. And my label is feet. Okay, on the area of the sector, even though this doesn't look like a traditional slice of pizza, it's not the full circle, but it's a portion of the circle, so a portion of the area. Our fraction of the area is we want 5/6 of the area, and the area is 49 pi. 5 and 6 aren't reduced. We have to check the diagonal. 6 and 49 will not reduce, so I'm going to multiply straight across the top and get 5 times 49, which is 245. So I have 245 pi over 6. And because it's area, it's going to be feet squared. All right, last one. The radius is 12, so the circumference is 24 pi millimeters. The area is going to be 144 pi millimeters squared. And this 45 is for this arc, but it wants arc ACB, which is the big part. So we have to do 360 minus 45, which is 315. So to get the arc length, we're going to take the degree, which is 315, over 360 times the circumference, because we want a fraction of the circumference. We don't want the whole way around. We just want part of the way around. Well, I can't divide those by 10, but I can divide by 5. 315 divided by 5 is 63. 360 divided by 5 is 72. I can keep reducing because both of those are divisible by 9. 63 divided by 9 gives us 7, and 72 divided by 9 gives us 8. So if you wanted to, you can copy that reduced fraction over here so it's ready for you. Now we can reduce in an angle. 24 and 8 are both divisible by 8. 28 divided by 8 is 1. 24 divided by 8 is 3. So I multiply across the top and I get 21 pi millimeters. All right, for the last one, for the area, we want a fraction of the area. We don't want the whole circle. We just want everything that's shaded. So we want 7/8 of the circle. So I'm going to take 7/8 times 144 pi. And the 7 and 8 won't reduce, but 144 and 8 will. I can divide them both by 8. So 8 divided by 8 is 1. 144 divided by 8 is 18. And now when I multiply straight across the top, I get 126 pi. And on the bottom, I get 1, but it's not necessary to write when the 1 is on the bottom. Okay, use this notes now that you filled it out to complete your homework.